This is an excerpt of a conversation between J. Craig Venter and Emil Jacobs, brought to you by the Chemical Heritage Foundation's annual T.T. Chow Symposium.
As I sort of alluded to earlier, we're looking at a very large number of parameters in cells to change the efficiency. I mean, it has to get very efficient. We're talking about photons hitting photoreceptors and converting that light energy into chemical energy. So if we're going to produce 10 times as much hydrocarbon out of it, something has to work a whole lot better. And it's everything from redirecting the carbon use in the cell, so more of it goes to producing fat, to changing the photoreceptors themselves, changing what they see, what they don't see, affecting the amount of light. And I think one surprise, at least to me, is what most people would assume would be intuitive. If you just want to add more light and you need more photoreceptors, you just genetically add more photoreceptors. If you do that, you actually get the opposite effect. And we sort of notice this out in the ocean. If you look what's called the Chlorophyll Max, where you find most of the photosynthetic organisms, they're not right on the surface of the ocean. They pick their own depth that they go to, somewhere between 1 and 100 feet. And we have instruments that go down and measure where that chlorophyll max is. So why do they do that? They're actually filtering out light to get the wavelength of light and the amount of light they optimally need for growth. So we're trying to learn from nature how they do this in a more efficient fashion. So there's a lot of different components that go into this.